In a recent video, I put together this circuit. We have a 741 op amp here, and the way that we have it wired up, basically what we do is we have half of the breadboard voltage of 18 volts there at this point here, and so we can either think of it as 18, 9, and negative 18 to the blue rail, or we could think of it as positive 9 volts at the red rail, 0 volts, and then negative 9 volts at the negative rail. The negative rails on both sides and the positive rail on both sides are connected with these jumpers. So, in any case, the power is on, the LEDs are off because we have this trim pot also set about halfway. If we go towards the positive side, turn towards the positive side, the red LED comes on because now the output of this trim pot is more positive than our 0 volt reference point. And we can have current flow the other way to light this blue LED. So now we can see one thing I do not like about this circuit, and look how bright that blue LED is. So we have a 1 kilo ohm resistor limiting the current, which in this circuit works pretty nice for the red LED. And so it's 9 volts. We could go lower to 470 ohms would be just fine, and the red LED would be a bit brighter, but the blue LED would probably be a bit brighter too. And at some point they don't really get brighter when you add a little bit more current, but it may get brighter. But in any case, it is too bright. So what we're going to do, I drew this out just to show that sometimes the output, we're going to talk about current as if it's going positive to negative, because originally that's what they thought. And so like the schematic diagram here, you can see if you want to light an LED, you have to put the side of the arrow, the wider end down there, more positive, and then it's pointing towards negative. So when you're looking at schematics and stuff, it's just easier to follow positive to negative because that's generally how the arrows are pointed. But in any case, when the red LED is light up because of how we wired it, we put the anode towards the positive side of the power supply, and the negative side to our virtual ground for when it lights up. Sometimes this will be more negative, it won't light up. But when it's lit up, we know that the trim pot is more positive than ground. And so that current has to go through a 1 kilo ohm resistor. The blue LED, we have the opposite situation. The anode, the long lead, is to the 0 volt reference point because we want it to light up when the cathode here gets more negative, and when the trim pot is more negative. So in any case, we're going to make our first fix. We're going to not use the same resistor to light the LEDs. So in fact, we can put this one up here. Again, this blue one lights when the anode is more positive and the trim pot more negative. So we want the cathode towards the trim pot. The longer lead, the anode, we're plugging right where that 0 volt reference point is. And so we got just the cathode down here by itself. We're going to take a 3 kilo ohm resistor instead of the 1 kilo ohm. So they are now parallel, but they're still LEDs that only light when current goes in one direction. So again, we'll go to the red one, lights like it normally did. Blue one is off, of course, because we have 9 volts now. And also the trim pot's adding resistance that, until we get all the way to the rail, that is also keeping the LEDs a little more dim than they would be until you get to the rail. But in any case, there you can see the blue LED is still more obnoxious than the red one, but not as bad. And so we could even go up a little bit more with the resistance. But in any case, that's a simple fix we could make, and so we did. So basically we just wired up these two circuits independently of each other, even though they are both connected at the negative rail and at our variable voltage. So we're getting the same effect as this, except for the blue LED now has more resistance, because the resistors have and the LEDs have two separate paths in this case. So in any case, hopefully that helps you understand this circuit a little more. If you didn't see my earlier videos, I took the power supply 18 volts, and using the 741 op amp in this case, I split that voltage. So we have a 0 volt reference point, but one side of the circuit now is 9 volts more positive when you start at the red rail, or 9 volts negative if you start at the blue rail. And of course the trim pot connects to both of them, and it can slide. So now instead of going from 18 volts down to 0 volts, we can think of it as positive 9 volts, 0 volts, or negative 9 volts. But again, remember, this has high, what you would call input impedance, and so it has resistance that also limits current you have to take into account. But this is just a basic demonstration circuit to show the polarity indicator being added to our virtual ground. So thanks for watching, and I will see you in the next video.